Hi there, folks. This is a review of polynomial function, and as always, I am the amazing Mr. Jansen, so away we go. If we look at this first one, we're finding a couple of different things here, starting with increasing and decreasing. And when we're looking at increasing and decreasing, we always want to look left to right. Basically, I'm looking at my x values and then breaking my x values into intervals and deciding where is this thing going up, where is it going down. And when you're looking for increasing and decreasing, look for positive and negative slope. Like here, the function displays a negative slope, which means it's decreasing on that section. Here it's displaying a positive slope, so it's increasing. Here's a negative slope again, and here's a positive slope again. And at the ends of each of those, it's not doing either of those things. At these turning points, it's not increasing or decreasing. It's kind of caught in limbo here. So as I look down through this thing, the things that are in green are increasing. So I look at the x values. It's increasing from here to here. All right, so for this one, it's increasing from -3 to 0. And neither of those values is included because at -3, I have a turning point. At 0, I have a turning point. It's also increasing from here on up. And so I described that as well. So I put a union symbol in. So it's increasing from 3 to positive infinity. All right. I do the same thing with the decreasing sections. So this section over here, from forever to the -3. So in other words, from negative infinity to a -3, it's decreasing. And then it's also decreasing in this section right here, from here to here. So it's decreasing from 0 to +3. All right, and that's interval notation. Again, when we're doing this, we're using interval notation to describe these things. And now in terms of relative maximums and minimums, these are just relative high points. Again, they're high points relative to the points around them. So this one right here, that is a relative maximum at 0, 0. It's a point that's higher than all the points around it. And then in terms of relative minimum, there's actually two of these. This is a relative minimum because it's lower than the points immediately next to it. This is also a relative minimum because it's a minimum relative to the points immediately next to it. So I've got two of these. I've got one at -3, -4. And I also have one at 3, -6. Okay, so I have two relative minimums. Again, it's relative to the points directly around it. And then end behavior, I look at each end. So I look as x going to negative infinity, and then I look at x going to positive infinity. When I talk about negative infinity for my x, I'm essentially looking at the left side of my graph. So right here, what's the arrow doing? It's going up. So as x goes to negative infinity, f of x goes to positive infinity. And then the same thing on the other end. For positive infinity with my x, it means I'm looking at the right side of my graph. So I look at this arrow. As x goes to positive infinity, f of x goes to positive infinity. So that's my end behavior. All right, that's just review. In terms of the next one, increasing and decreasing. Again, for this one, I'm increasing when I have positive slope. That's on those sections. I'm decreasing when I have negative slope. And then the things in between, these are my turning points, and the turning points are neither increasing or decreasing. They're kind of staying the same for a moment. All right? So in terms of increasing, it's increasing from over here until I get to this value. So it's increasing from negative infinity to a -2. And then it's also increasing from here on up. So it's also increasing from 1 to positive infinity. And then it's decreasing in between here from this value to this value. So it's decreasing from -2 until I get to +1. All right. Again, increasing, decreasing, I always read it left to right. And then in terms of relative maximums and minimums, again, these are points that are maximum relative to the points around them or minimum relative to the points around them. So here, this is a relative maximum. This one is a relative minimum. So there's a relative maximum at -2, +3. And there's a relative minimum at 1, -3. And then end behavior. End behavior is always defined the same way as x goes to negative infinity. And then x going to positive infinity. X going to negative infinity essentially is the left side of my graph, and it's pointing down, so f of x is going to negative infinity. X going to positive infinity is essentially the right side of my graph, which is right here, and the right side of my graph is going up, so that's going to positive infinity. Okay? And number 3, I want to write the equation of the polynomial given the zeros and given the y-intercept. And keep in mind what each of these zeros means. If I have a 0 of -4, that means x equals -4, which means I have a factor of x plus 4 somewhere in my equation. All right? It's the same thing here with the +1. Means I have x equals 1, which means I have x minus 1 as one of my factors. And then the last piece, the last of these, I'm going to have an x minus 2 as one of my factors. All right? So I know I have these three factors somewhere in here, so y equals these three factors being multiplied. But I might also have an a value thrown in here that's unknown to me just yet. So there could be an a value, a constant term being multiplied by all of these. And the y-intercept will tell me what that constant term is. Keep in mind that this y-intercept, this is the ordered pair 0, 2. So I can just plug that x and y value in to find my a. So I plug the 2 in for y. I plug a 0 in for each of these x's. And I just solve for a. So I've got 2 equals a times 4 times a -1 times a -2. So I've got 2 equals an 8a. And so I divide each side by the 8 and find out that a equals 1/4. Okay? And I'm not done yet. This asks for it in standard form. So when I do this, I have y equals 1/4, my x plus 4, my x minus 1, and my x minus 2. This is in factored form. If I want it in standard form, I have to start multiplying all this stuff out. And that's it. Number 4 is essentially the same thing, except this time instead of telling you that x equals a -5, I wrote it as an ordered pair -5, 0. But it means the same thing. It means I have the factor x plus 5 around here somewhere. I also have the factor x plus 3. And then the last one over here, I also have the factor x minus 3. Again, there's an unknown a value here. But I gave you the y-intercept again. Here's the x and the y that you're going to plug in. So I plug each of these in. So I plug a -20 in for y. I plug a 0 in for x, which gives me a 5, a 3, and a -3. So I've got -20 equals. That's going to give me a -45a. I divide each side by 45, and I find out that a equals a 4/9. And so now from here, I want to write this in standard form. Y equals 4/9 times these guys. And once again, I'm just going to multiply all this out. And that's it. For number 5, I'm looking for a common difference here if I want to identify the degree of the polynomial. So I look at the difference here from here to here. That's a 3, a 5, a 7, and a 9. And so those aren't common, so I look at the second difference. So I take the difference of my differences. That's a 2, and a 2. Since the second difference is common, it means this is a second degree polynomial. See, first difference, second difference. So this is a second degree polynomial, which means I'm looking for y equals ax squared plus bx plus c, which I'm going to let the calculator do the work for me on this one. So I bring my calculator up. I go into stat, so I hit the stat button right here. Under stat, I click edit. And now I'm going to punch each of these into my list. To clear the list, I hit clear and back down into the list. So I'm going to punch this in. And then once I have this information punched in, I go back to the stat button right here. So I hit stat, over to calculate. And this is why I went and found the degree of the function. Since I know that this is a second degree function, it means I'm looking for a quadratic. So I go down to number 5, which is a quadratic regression. Hit enter. I tell it to calculate. And it essentially gives me my equation. It tells me that y equals 1 is a, so 1x squared plus 0x plus 3 That's an ugly looking 3, which means my equation here is y equals x squared plus 3. And that's it. Okay? I'm going to do the same thing essentially with the next one, if I can cover this guy up for a moment. Over here, I'm looking for those differences first. So from here to here, that's a negative 2 because it went down, and then a positive 2, and then a, get that out of the way, and then a 12, and then what looks like a 28. So that difference didn't work, so I look at the second difference. From negative 2 to positive 2 is a 4. This would be a 10, and this would be a 16. And so that didn't work, so I go to my third difference. My third difference here, that's a 6. Here, that's a 6. So the third difference works, which means this is not a 1, 2, but it's a third degree polynomial, which means I'm looking for something of the form y equals ax cubed plus bx squared plus cx plus d. Okay? So third degree, so I get my calculator back out, and I go through the same process. This time when I go to calculate, I know I have a third degree function, so I go down to cubic regression because now I have a cubed function. So it gives me the equation y equals a, which is 1x squared minus 4. Sorry, this would be a cubed. Minus 4x squared plus 3x plus 2. That's it. Okay?